Hey everybody, welcome to Algebra 2 Priority Standard 7. So we are here on our last priority standard of the year, and this one is on radical functions. So to recap everything that we've done this year so far, we started off with linear functions. These were equations that had a graph which was a straight line, and the equation had the form y equals mx plus b. From there, we moved on to quadratics and then to polynomials. So these were graphs that were either a parabola or some kind of swoopy-whoopy up and down shape, where we had either an x squared term or a higher power of x, x to the third or x to the fourth or something bigger than that. Then we moved on to exponential functions. So these had graphs that were shaped kind of like hockey sticks, where we had either exponential growth or exponential decay. And those all had a variable in the exponent. So these equations all had the form y equals some base to the power of x plus a constant. Then in our last unit, we talked about rational functions, or functions that were ratios or fractions. So these ones typically had multiple sections to their graphs, something like that, with horizontal and vertical asymptotes in between. And this came from having a variable in the denominator of the fraction. So things like y equals 1 over x, or y equals 1 over some other kind of polynomial. So that is what we have done so far this year. And in Priority Standard 7, we are going to introduce one new type of function, and that is a radical equation. And a radical is a square root or a cube root or a fourth root, some sort of a root function. So the graphs of these ones look like half of a sideways parabola. So in that way, it's a little bit related to our quadratics back from Priority Standard 2. Those had equations of the form y equals x squared. Our radical functions here in Priority Standard 7 have equations of the form y equals square root of x. So instead of having a vertically oriented parabola, we have a horizontally oriented parabola, or at least a half of one, but you can visualize where the other half would be. So that is what we are doing in this last standard. And our first learning target on the 2.0 level is that given a table of x values, we're going to fill out the table, graph, and describe the domain and range of a radical function. So this is all in your new notes packet. We are going to be starting off on page 5. This is learning target 7.2.1 and box 1. And it says graph the following. Y equals the square root of x. So we're going to start nice and simple. Square root of x is the simplest radical function that you could have. So let's think about what x values would be nice to plug into this. What x values do we know the square roots of? Well, we're going to start with 0, but then let's think about what other numbers are perfect squares. Numbers like 1 and 4 and 9 and 16 and 25. So if y is the square root of x, then the square root of 0 is just 0. The square root of 1 is 1. Square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. And the square root of 25 is 5. So I'm going to run out of room to graph all of those points, but we can definitely plot the first few of them. X value of 0, y value of 0, there's a point at the origin. Then we have an x value of 1, y value of 1, so over 1 up 1. Then we have x is 4 and y is 2, so over 4 and up 2. And the last one that I'm going to have space for on my graph is an x value of 9 and a y value of 3. So over 9, up 1, 2, 3. And that's enough to draw in the shape of this. Like I said, radical functions have a graph that is sort of a sideways parabola. And I want you to notice that we started here at the origin. We started at x is 0. And that makes sense because you can't take the square root of anything that is negative. So if I tried to take the square root of, say, -4, then y would be an imaginary number. There's no spot for that on the graph. So whenever you're filling out one of these tables, you want to make sure that you're using x values that you can actually take the square root of. So in this case, anything that is bigger than or equal to 0. Now this is also asking me for the domain and the range. So remember that the domain is the set of all possible x values, and the range is the set of all possible y values. So my x values, I had to start at 0. I can't take the square root of anything negative, so I had to start at 0, and then it goes in the positive direction. So if we wanted to label this on the number line, we would say x is greater than or equal to 0. Or if we wanted to use complete notation, we would say x can be any real number such that x is greater than or equal to 0. Now the range is the set of all possible y values. And that's going to be pretty similar here. Notice that as I'm going up and down along the y-axis, the lowest spot is again a y value of 0, and then from there my graph is going up, so my y values are also going to be going up. Y is anything greater than or equal to 0. Or in full out notation, we would say that y can be any real number as long as y is greater than or equal to 0. So that is the graph of the simplest possible rational function. Now let's look at one that's a little bit more complicated. In this instance, we have the equation y is equal to square root of x minus 4 plus 3. So if we want to fill out the table of values, the first thing we need to ask ourselves is where would we start? And remember that we can only take the square root of things that are positive, that is greater than or equal to 0. So in this case, when I'm taking the square root of x minus 4, that has to be positive. It has to be greater than or equal to 0, or my answer will be an imaginary number. Well, if x minus 4 needs to be greater than or equal to 0, I would add 4 to both sides of the equation and end up with x having to be greater than or equal to 4. So when I start my chart of values, I would start off at 4 and then go from there. And we can plot 5, 6, 7, 8, and 9. So if I plug in the square root of x minus 4 plus 3, that's the square root of 4 minus 4 plus 3. Well, that's the square root of 0 plus 3, so it just ends up being 3. If I plug in an x value of 5, that's the square root of 5 minus 4, which is 1. Square root of 1 plus 3 gives us a y value of 4. And then we might end up with some numbers that need to just be plugged into the calculator. So you do the square root of 6 minus 4, right arrow key or close parentheses to end your square root function, and then plus 3 on the end. Well, 6 minus 4 is 2, so you would do the square root of 2, which is about 1.4, plus 3 gives us about 4.4. Then we would do the square root of 7 minus 4 plus 3. 7 minus 4 is 3. Root 3 is 1.73. And then add 3 to that, we get 4.7 approximately. Plugging in 8 for x, we've got the square root of 8 minus 4, which is the root of 4, or 2. 2 plus 3 gives us 5. And then last one here that we'll plug in, an x value of 9. 9 minus 4 is 5. The square root of 5 is about 2.2. And then adding 3 to that, we get 5.2. So when I go to graph this, my first point is an x value of 4 and a y value of 3. So over 4, up 1, 2, 3. Next, I have an x value of 5 and a y value of 4. So I plot that point. Then I have 6, 4.4. So over 6, up 1, 2, 3, 4, and not quite a half. Then I have 7, 4.7. So I still haven't gotten quite up to a y value of 5. But here I do, x value of 8, y value of 5. That point right there. And then an x value of 9, a y value of 5.2. So connecting the dots here, my graph is going to look something like that. So when we want to find the domain and range, again you are asking yourself, what set of x values do we have? And I'm starting here at 4, and then everything from there goes to the right. So I have x values greater than or equal to 4. So we would say x can be any real number such that, or as long as, x is greater than or equal to 4. Then for the range, we're looking for the y values. So my lowest possible point here, the bottom of this curve, this starting point, is at a y value of 3. And then the whole graph goes upwards from there. So y is greater than or equal to 3. So we would say y can be any real number such that y is greater than or equal to 3. And you might notice a connection between the domain and range and the original equation. So on my domain, I ended up with x is greater than or equal to 4. 4 was the starting value on my graph that I got from this little equation up top here. And that is the reverse of what was under the square root sign. So x minus 4 under the square root told me that x had to be 4 or greater before my square roots would end up being positive values. And then my range was y is greater than or equal to 3. That came from the constant added on at the end of the equation. I have a plus 3 at the end. That gave my starting point a vertical shift of 3. So instead of starting at 0, my y value started at 3. So let's look at box 3 here. Again, our first step is to decide where does x start. Then we'll fill out the table and figure out domain and range from there. So where do we start? Well, when I'm taking the square root of something, that something has to be positive. So if my something is x plus 3, well, x plus 3 had better be positive. It better be at least 0 or bigger so that I don't end up with an imaginary answer. Now, if x plus 3 is greater than or equal to 0, I need to subtract 3 from both sides, and you'll end up with x is greater than or equal to negative 3. So my starting value will be at negative 3, and my table will go up from there. Negative 3, negative 2, negative 1, 0, 1, 2, and we'll stop there. So now I'm going to plug in these values of x and see what the y values end up being. So we've got the square root of x plus 3 minus 7. So the square root of negative 3 plus 3 is the square root of 0, which is 0, minus 7 equals negative 7. Let's try the next one. Square root of negative 2 plus 3. That's the square root of 1, which is 1. And then minus 7 would be negative 6. Square root of negative 1 plus 3. That would be the square root of 2, which is approximately 1.4. And then the minus 7 takes me down to negative 5.6. square root of x plus 3, where x is 0. Square root of 0 plus 3 is the square root of 3, or approximately 1.7. 1.7 minus 7 gives us negative 5.3. If the x value is 1, then have the square root of 1 plus 3, or 4. The square root of 4 is 2. 2 minus 7 gives me negative 5 even. And then if x is 2, the square root of 2 plus 3 is the square root of 5, or about 2.2. 2.2, and then minus 7 gives us negative 4.8. So if I go to graph this, my starting point is at x is negative 3, y is negative 7. So I start there, and then I have points at negative 2, negative 6, negative 1, negative 5.6, so about negative 5.5, 0, negative 5.3, so just a little below negative 5. X is 1, y is exactly negative 5, so that one is right on the crosshairs. And then x is 2, y is negative 4.8. So I'm starting at negative 3, comma negative 7, and curving up like so. So for the domain and the range, notice that these are all connected with my starting point. So if my starting point is at negative 3, comma negative 7, then everything is to the right of there, and everything is above that point. So everything is to the right of negative 3, and everything is above negative 7. So the domain, x can be any real number such that x is greater than or equal to negative 3. And that shouldn't come as a surprise. We had that up here at the top already when we were figuring out that our starting point was going to be at negative 3. And then the range comes from that starting point y value. We would say that y can be any real number as long as it's greater than or equal to negative 7. So to sum up here, radical functions always have the form y equals the square root of x minus h plus k. So the domain always comes from the part under the square root sign. So the domain is always x is greater than or equal to h. So it's going to be the reverse of whatever is under the square root sign. So if you have x minus 4, then the domain would be x greater than or equal to 4. If you have x plus 2, the domain would be x is greater than or equal to negative 2. And the reason for that is because we need to take the square root of a positive number. So the domain is always x is greater than or equal to h, because square roots are only real for numbers greater than or equal to 0. And the domain, that always comes from the constant that's added on at the end of the function. The domain is, that should say always. The domain is always y is greater than or equal to k, because k is the vertical shift. So if you think back to your translations, you would have a horizontal shift given by the h value. K is the vertical shift. You could also think of it as being the starting y value. So if you know this, then you can figure out the domain and range without even plotting a graph. Now, plotting a graph is still helpful, but it's a good way to double check yourself. The domain is always going to have the form x is greater than or equal to some number. The range is the set of y values. It's going to have the form y is greater than or equal to some number. And then the two numbers come from the equation. The x values get reversed. So if we have x minus 3 in the equation, then the domain is going to be x greater than or equal to positive 3. If we have x plus 3 in the equation, the domain as x is greater than or equal to negative 3. And if we have negative 2, we reverse that and have x is greater than or equal to positive 2. So because we have this little negative sign here in our standard form equation, there's a reverse there. The range comes straight from the vertical shift or the starting y value. So if it's a square root plus 2, then the range is y is greater than or equal to 2. If it's plus 3, then it's greater than or equal to 3. If it's minus 9, then it's greater than or equal to negative 9. So that's all you need to know for this 2.0 level learning target. Knowing how to find the domain and range just by looking at the equation is a very useful skill. You also want to be able to start with a useful x value and create a table of values so you can plot a graph. If you can do those things, then you are all set for learning target 7.2.1.